Now, for this problem that we have here, it says a quadratic equation gives us the roots of a quadratic and the axis of symmetry. Then that means that the x-coordinate of the vertex is found using this thing. All right, x is equal to negative b over 2a. So we've mentioned that in the two examples before. So if you think about it, this is nothing more than just the axis of symmetry, right? So it's just a very special case that comes out as a result of the derivation when we're completing the square. We use negative b over 2a as our axis of symmetry if we had left it, if we hadn't simplified it. So now, if we hadn't simplified our solution for 0 equals ax squared plus bx plus c. So now let's go over what's happening here with our parabola. So just like before, we're always going to start by writing our basic equation. If I look at this, I know I can factor this, right? It's like I need a number that multiplies to negative 24 and adds to positive 5. And, you know, I do my factoring by grouping, and I get something like this. And then I factor, I take the GCF of the first bracket, I get 2x. And I take the GCF of the second bracket, I get minus 3. And then we end up with something like this, which means that our x-intercepts for this equation are, and so we have our x-intercepts to be negative 4, and when we simplify that second bracket, 2x plus 3 equals 0, we end up with 3 over 2. Now, remember what I told you. The axis of symmetry is going to be negative b over 2a, so we'll use that. So let's calculate that, and then what we're going to do is we're going to take that and plug that back into our original equation. Now remember, this stuff here comes from this equation. So anytime we have an equation that looks like y equals ax squared plus bx plus c, we can use that to find the axis of symmetry right away. So now, once we've done that, we're going to take our equation, we're going to substitute all those values in, our b and our 2a. And so we're left with this as our final equation for our axis of symmetry. Now, let's take that axis of symmetry and before we used to go and take the two x-intercepts, find the halfway point, plug it in, and then we were good to go. Now, we just use this axis of symmetry, which cuts down on our work so much. We now go and take this, and we're going to let our original equation, 2x squared plus 5x minus 12, equal y, because we want to know what y value gives the vertex for that quadratic. So now we're going to substitute x is equal to negative 5/4. That's what we used to do anytime we found the axis of symmetry, into what I'm going to call equation 1, which is our equation for our problem to find our y value. So now when we substitute, we get y is equal to all this ugliness. And all we're going to do is substitute this part, the negative 5/4. So let's do so right away. So we're going to get 2. Now, negative 5 over 4 squared. So you have to think about applying the negative 5 and squaring it. What do you get? You get 25. And then you square the bottom as well, you get 16. So we end up with 25 over 16 times 2. And then we have plus the rest of this. Now, you multiply it. You multiply negative 5/4 times positive 5. You end up with negative 25 over 4. And then negative 12 is really negative 48 over 4. So what I'm going to do is I'm going to take my time and I'm going to make sure that I put these two things together, so that we make our final, and then we're going to also simplify this in my next line. So now when we do that, we're going to get y is equal to 25 over 8 plus minus 73 over 4. All right. Now that we've got that, we're going to go and take our 73 over 4 and we're going to turn it into 2 over 2. by multiplying it by something over, by 2 over 2 to give us something over 8. Now, let's simplify. So we end up with y equals 25 over 8 minus 146 over 8, which turns into, when we simplify, y is equal to negative 121 over 8, which means the vertex of my parabola is negative 5 over 4, comma, negative 121 over 8. If you guys can find an error in this slide, which I haven't checked, I will give you an extra grade on your check-in. Good luck, guys.